At the end of last year, we interviewed 1,000 VPs and executives from a wide range of industries to get a clear picture as to how their companies were weathering outages and what they were doing to achieve operational resilience. And here's what we found. Of the 1,000 people we spoke to, 95% of them were aware of weaknesses in their operational resilience. 93% were so worried about their weaknesses that it was keeping them awake at night. 79% admit to not being ready for DORA, the Digital Operational Resilience Act in Europe. And 44% admit to having serious concerns over their organisation's ability to comply with DORA. Only 2% of the people we spoke to were confident that their systems could recover in less than 1 minute. Scarily, 100% of the people we spoke to have lost money in the last 12 months as a result of an outage. On average, a company was experiencing 86 outages per year, equating to around 324 minutes of outages per week, with 55% of the people we spoke to experiencing weekly outages and 14% of people we spoke to experiencing daily outages. 32% of people reported losses of over $100,000, and larger companies are 3.5 times more likely to experience outages costing over $1 million. With DORA now in force, losses as a result of outages are only going to go up, and that's because of the penalties involved. DORA will fine companies either $5 million or 1% of annual revenue, whichever's higher, if a company is found to be in breach of the regulation. And DORA is not the only regulation, and it's not the regulation that imposes the largest fines. As with data privacy regulations, resilience regulations can be found across countries and continents, whether it's DORA in the EU or the CPS 230 in Australia. It really depends on where you do business. You might be subject to DORA and not realise it. If you're doing business within the EU, you're subject to DORA. I see these regulations as an opportunity for businesses to make meaningful changes to their IT infrastructure. And I recently attended a webinar hosted by Finextra, see a link in the description, where I talked with industry experts about just this. In short, we have to do better. And happily, technologies like CockroachDB are already helping organizations to get closer to their goals of operational resilience. Today, I'll talk you through what we at Cockroach Labs refer to as defense in depth and how that can bolster your organization's operational resilience. When talking about resilience, you'll often hear about RTO and RPO. RTO, or Recovery Time Objective, is simply the amount of time it takes you to recover from an outage, whilst RPO is the amount of data you'll lose in an outage. In a traditional monolithic database, RTO and RPO might look like this, where time is going across here. This is business as usual. At this point, we make the last backup, let's say an hourly backup schedule, and everything up to the event we've just had our outage is data loss. If we've lost a disk and that data isn't backed up, all of that data, and that might be an hour's worth of data, is gone forever. Everything from the event to the recovery time is downtime, and that's the RTO. Contrast this to RTO and RPO in CockroachDB, and it looks quite different. Time is moving along as it did in the last example. We've made a backup, as you should do with any database. And when we hit our event, because data is replicated across machines, there's no data loss, RPO is 0, and RTO can be measured in seconds, typically less than 10. So the experience of the applications and your users is more of a blip that can be retried. And when we talk about CockroachDB's ability to run across multiple machines, we tend to refer to it as multi-active availability, differing from primary standby and differing from active-active. I'll post a link in the description to our documentation on what I mean by that. Consider CockroachDB's default method of operation, which is multi-active replication. Every node contributes to the workload. That's both for reads and writes. There's no concept of a master node or a primary node or a writer node. Data is replicated across the nodes to ensure consistency and integrity of data in the event of an outage. Let me show you what I mean. In this example, we have users on the left talking to a cluster of CockroachDB nodes on the right. The requests are going from the users, being routed to random nodes in the cluster, and you can see that data is being replicated between the nodes, such that if any of the nodes were to go down, aside from maybe a transaction retry, the users aren't affected by it. The two remaining nodes pick up the slack and the database continues unaffected. And when the node comes back online, data is up-replicated from the other nodes. And if this happens to any of the nodes, any in-flight requests can be retried and data is up-replicated when the outage is over. Contrast this to a monolithic database and things look quite different. We have our single instance of the database with all requests going to that. But if that database node goes down, the application is down and there are no other nodes to pick up the slack Perhaps you're now frantically trying to restore from backup or bring on a secondary database, and that could take minutes, hours, or days, depending on the size of your dataset. But if you manage to get things back online, business can continue as normal. It's important to appreciate that downtime extends beyond unplanned outages. If every time you update or modify your system, you take it down for maintenance, that's still downtime. To minimize disruption, you might decide to make these changes out of hours or over weekends. And 48% of the people we spoke to are already having to do this. Because CockroachDB runs across multiple nodes, not only do unplanned outages become less of a concern, version upgrades and infrastructure changes can be made during the day when your team are available. And CockroachDB also supports online schema changes, meaning that even if you're making large, sweeping changes to your database schema, your applications will be unaffected and business can continue as normal during these changes. So no more out of hours or weekend working for your team. Typically, a monolithic database will be deployed on one machine. Let's take a look at different deployment topologies and how they can work to safeguard your workloads. First, we have the single server setup. If your database is running on a single server, and that server runs out of disk or memory or any other kind of hardware fault, your application is out of action. If you're running across multiple machines, you can now survive outages that would affect a single machine, and you can also bring machines in and out of a cluster for repaves or OS updates. So looking at a deployment of multiple machines within one data center, while that's better than running across one machine, if that building loses power, the application is also lost. So taking it a level higher, you might want to consider running across multiple geographic locations. In the event that one of those loses power or goes down, your applications can continue to function. This is just an example. You might not require 3 database nodes in each building. But let's go a level higher. If these 3 buildings represent 3 availability zones in a cloud, or these are just 3 data centers in close proximity, looking back to 2012, the world suffered its worst power cut in history, and it affected 600 million people in northern India, 10% of the world's population at the time. For this reason, some of our customers choose to run across wider geographic areas, allowing them to survive some of the worst outages that nature can throw at us. Think forest fires or the power cut in India. We appreciate that multi-active replication running across 3 nodes or 3 data centers can't serve every customer. Perhaps you're running across 2 data centers and don't have access to a third, or can't run in the cloud to create a hybrid environment. For those customers, we created physical cluster replication. And this makes the process of disaster recovery more straightforward and safer, resulting in lower RPO and RTO than you would otherwise be able to achieve with simple backup and restore. Let me show you what PCR looks like. In this example, we have a primary and secondary cluster, and these might be across 2 data centers, for example. Customers are talking to the primary data center, and the nodes within that primary data center are replicating data. If any of those nodes go out, the application continues, but in the event that the primary data center goes down, the secondary data center can take over, serving customer requests, and replication can be reversed so that data is then being replicated to the old primary, or now the new secondary. And that can continue until the primary data center is available again, at which point a safe failback can occur and bring everything back to normal with customers once again talking to the primary data center. Hopefully that gives you an idea as to how CockroachDB can satisfy the operational resilience of a wide variety of companies, whether they're running in cloud, on-prem, or a mix of the two. I think it's important to reflect on the fact that 100% of the people we spoke to were still losing money as a result of outages. What we're doing at the moment with traditional disaster recovery isn't enough to safeguard our workloads. Businesses need to start turning to operationally resilient technologies to achieve their goals of being always available. If what we were doing were enough, we wouldn't have DORA.